Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
You've completed 15 episodes. Aurora Global Database, DynamoDB Global Tables, EKS Multicluster, Network Architecture, Observability, DNS Failover, Cost Management, CAP Theorem, Service Mesh, Disaster Recovery, Compliance, Security, and Anti-Patterns. You understand the theory. You know the building blocks. Now the critical question: how do you actually execute this? How do you go from single-region production today to multi-region production in 90 days without causing outages? Today you're learning the implementation roadmap, not vague guidance. A concrete, phase-by-phase plan with weekly tasks, go-no-go decision criteria, and rollback procedures. By the end of this lesson, you'll have the complete 90-day timeline. Phase 1, assessment and foundation. Phase 2, data layer migration. Phase 3, compute layer deployment. Phase 4, validation and cutover. Dependencies between tasks. Risk mitigation strategies. When to abort if reality doesn't match plan. Because knowledge without execution is theoretical. Let's turn 15 episodes into production reality. The 90-day timeline has 4 phases of roughly 3 weeks each. Each phase has deliverables, validation criteria, and go-no-go gates. If phase validation fails, you don't proceed. You fix issues or abort. Phase 1, days 1 to 21, assessment and business foundation. Week 1, days 1 to 7, business case development. Use episode 9's ROI framework. Calculate revenue per hour. Estimate annual outage hours without multi-region. Calculate multi-region incremental cost. Present analysis to business stakeholders. Get written approval or kill project here. Example calculation for 50 million revenue company, 50 million equals 5,700 per hour. Expected outage without multi-region, 8 hours annually equals 45,600 cost. Multi-region incremental cost, 300,000 annually. Break-even requires 65 hours outage. If realistic, proceed. If not, consider alternatives like improved backups or faster recovery procedures. Deliverable. Approved business case with signatures. Budget allocated. Timeline agreed. Week 2, days 8 to 14. Architecture design and team planning. Choose pattern from episode 2. Hot-warm for most cases. Hot only if justified by RTO under 1 minute. Document architecture diagram. Identify which services replicate, which stay regional. Assign team roles. Who owns data layer, compute layer, networking, observability. Critical decision. Choose secondary region. Episode 5. Guidance. Same geography for lower latency. Different geography for disaster isolation. US East 1 primary, US West 2 secondary for latency, or EU West 1 for diversity. Document rationale. Deliverable. Architecture diagram approved. Team assigned with clear ownership. Secondary region selected. Week 3, days 15 to 21. Network foundation. Implement cross-region connectivity from episode 5. VPC peering for simple architectures. Transit gateway for complex. Test connectivity with basic EC2 instances in each region. Verify latency matches expectations. Set up VPC endpoints for AWS services in secondary region. Configure security groups for cross-region traffic. Validation test. Deploy test application in US East 1. Test application in US West 2. Verify connectivity. Measure latency. Should match episode 5 numbers, under 80 milliseconds for US cross-region, under 150 milliseconds for US EU. Deliverable. Network connectivity working. Latency validated. Security groups configured. Go, no-go gate 1. Do you have business approval, architecture design, and working network? If yes, proceed to phase 2. If no, do not proceed. You'll waste engineering time and money. Phase 2, days 22 to 49, data layer migration. Week 4, days 22 to 28, Aurora Global Database setup. Create Aurora cluster in secondary region following episode 3. Add secondary region to existing primary cluster. Monitor replication lag. Should stabilize under 100 ms. If lag exceeds 200 milliseconds consistently, investigate before proceeding. Configure read replicas in secondary. Test read queries against secondary. Critical configuration. Encryption at rest. From episode 14, choose per region KMS keys for security or multi-region keys for faster drive document decision. Validation test. Write to primary Aurora. Verify replication to secondary within 100 ms. Query secondary read replica. Verify data matches. Deliverable. Aurora replicating with acceptable lag. Read replicas functional. Week 5, days 29 to 35. DynamoDB Global Tables, if applicable. From episode 6, identify which tables need active writes. Not all tables. User sessions stay regional. Transaction tables, product catalogs, user profiles. These replicate. Enable global tables selectively. Monitor replication lag and WCU consumption. From episode 15, Anti-Pattern 5, watch costs carefully. Cost checkpoint. Compare actual DynamoDB spend to projected. If actual exceeds projected by 20%, investigate before proceeding. You may have replicated wrong tables. Deliverable. Selected DynamoDB tables replicating. Costs within projections. Week 6, days 36 to 42. Backup validation and failover testing for data layer. Take Aurora snapshot in primary. Restore to secondary region. Verify KMS permissions allow decryption. Time the restore process. From episode 12, this is critical for RTO calculation. Test Aurora promotion without affecting production. Demote immediately after testing. Validation test. Snapshot restore completes in under 15 minutes. Promotion works. Demotion returns to primary without data loss. Deliverable. Proven data layer failover procedure. Documented timing. Runbooks written. Week 7, days 43 to 49. Data consistency validation. From episode 10, test eventual consistency patterns. Write to US East 1, DynamoDB. Immediately read from US West 2. Observe replication lag. Design application logic to handle stale reads. Implement version numbers or sticky routing if needed. Verify Aurora read after write consistency from primary, eventual consistency from replicas. Deliverable. Applications designed for eventual consistency. Testing confirms behavior matches expectations. Go, no-go gate 2. Is data replicating reliably with acceptable lag? Can you fail over data layer successfully? If yes, proceed. If no, fix data issues before adding compute complexity. Phase 3, days 50 to 70, compute layer deployment. Week 8, days 50 to 56, EKS cluster setup in secondary region. From episode 4, create cluster matching primary configuration. Same instance types, same Kubernetes version, same add-ons. Deploy observability agents from episode 7. Configure CloudWatch logs, shipping, X-ray daemon. Deploy core infrastructure, ingress controller, service mesh if applicable. Don't deploy applications yet. Validation test. Deploy simple test pod. Verify logs reach CloudWatch. Verify traces reach X-ray. Verify pod can query Aurora secondary and DynamoDB. Deliverable. EKS cluster operational. Observability working. Connectivity to data layer validated. Week 9, days 57 to 63. Application deployment to secondary at reduced capacity. Deploy applications using same manifests as primary. Scale to 25% of primary capacity for hot-warm. Monitor pod health, database connections, external API calls. From Episode 4, configure service discovery to resolve to regional endpoints. Critical. Applications in secondary should not receive production traffic yet. Deploy and run healthy, but DNS doesn't route to them. Validation test. Call application endpoints directly via secondary load balancer. Verify responses. Confirm database queries work. Check error rates match primary region baseline. Deliverable. Applications running in secondary. Health checks passing. No production traffic. Week 10, days 64 to 70. Secrets and configuration replication. From Episode 14, enable Secrets Manager replication for application secrets. Verify secondary region applications can retrieve credentials. Test credential rotation. Rotate in primary. Verify update propagates to secondary within 60 seconds. Update application health checks to validate secret availability. Deliverable. Secrets available in both regions. Rotation working. Go-no-go gate 3. Are applications deployed and healthy in secondary? Can they access data and secrets? If yes, proceed to validation phase. If no, troubleshoot before attempting traffic migration. Phase 4, days 71 to 90, validation and cutover. Week 11, days 71 to 77, DNS configuration and gradual traffic introduction. Configure Route 53 from Episode 8. Set up health checks on primary endpoints. Create failover routing policy with primary and secondary records. Don't enable failover yet. Instead, create weighted routing sending 1% of traffic to secondary. Monitor error rates, latency, database load. From Episode 8, set TTL to 60 seconds. Monitor secondary scaling. Auto-scaling should handle 1% smoothly. Increase to 5% if no issues. Monitor for 24 hours. Increase to 10% if stable. Critical. Watch for issues from Episode 15, Anti-Pattern 6. Are you seeing excessive cross-region database calls? High latency? Data transfer costs spiking? Deliverable. Secondary handling 10% production traffic successfully. Error rates normal. Latency acceptable. Week 12, days 78 to 84. Failover testing with production-like load. Use Route 53 weighted routing to send 50% traffic to secondary. Temporarily reduce primary capacity to force secondary auto-scaling. Verify secondary scales from 25% to 100% capacity within RTO. From Episode 12, execute manual failover. Promote Aurora. Update Route 53 to point to secondary as primary. Monitor error rates during failover. Validation test. Failover completes within RTO. Error rates remain below 1%. Aurora promotion works. Applications remain healthy. Roll back to primary after testing. Deliverable. Proven full failover procedure. RTO validated. Team trained on execution. Week 13, days 85 to 90. Production cutover and documentation. Enable Route 53 failover routing. Primary becomes active with health checks. Secondary becomes standby with automatic failover on health check failure. Document runbooks from Episode 12. Train on-call engineers. Set up chaos engineering schedule from Episode 12. Plan first quarterly DR drill. Final validation. Trigger health check failure in primary. Verify automatic failover to secondary. Verify RTO meets requirements. Roll back after testing. Deliverable. Multi-region production live. Automatic failover configured. Team trained. Runbooks complete. Post-cutover checklist. Days 91 to 120. Operational maturity. Month 4. Cost optimization. Review actual costs against Episode 9 projections. Identify optimization opportunities. Right-size secondary capacity. Review DynamoDB table selection. Implement savings plans and reserved instances. Target 40% cost reduction via Episode 9 strategies. Month 4. Observability refinement. Build unified dashboards from Episode 7. Cross-region error rate tracking. replication lag alerts, cost anomaly detection. Set appropriate alert thresholds based on 3 months of data. Quarterly DR drills. Schedule first game day exercise from episode 12. Test complete failover end-to-end. Document what works, what breaks, update runbooks, repeat quarterly forever. Real-world example of successful 90-day migration. E-commerce company, 75 million revenue. Followed this roadmap precisely. Week 8 discovered Aurora replication lag exceeded 200 milliseconds due to large transaction volume. Spent extra week optimizing write patterns before proceeding. Day 85 discovered VPC endpoint misconfiguration breaking secrets manager. Fixed before cutover. Day 90 went live successfully. First DR drill, day 120, revealed outdated runbook step. Fixed immediately. 1 year later, 0 unplanned outages to secondary region, 3 successful failovers during primary region issues, RTO, averaging 4 minutes. When to abort the migration. Abort Criterion 1, business case invalidated. During assessment phase, ROI calculation shows multi-region costs exceed benefit by 5x or more. From episode 15, anti-pattern 1, don't proceed out of pride. Abort and optimize single region reliability instead. Abort Criterion 2, data layer validation fails. Aurora replication lag consistently exceeds 500 Ms. Promotions fail during testing. From episode 3, this indicates underlying architectural issues. Fix before proceeding or choose different database strategy. Abort Criterion 3. Cost exceeds projections by 100%. At day 49, if actual costs are double projections, you've miscalculated. From episode 15, anti-pattern 5, investigate and re-baseline before proceeding to compute layer. Abort Criterion 4. Team capacity insufficient. By day 60, team is overwhelmed maintaining multi-region. Engineering velocity dropped below 50%. From episode 15, anti-pattern 4, complexity exceeds team maturity. Either hire platform specialists or simplify architecture. Before we wrap up, pause and answer these questions. Question 1. At day 49, your Aurora replication lag averages 180 milliseconds, but spikes to 400 milliseconds during peak hours. Do you proceed to phase 3? Question 2. You've reached day 85. Failover testing works, but takes 9 minutes instead of 5-minute target. Do you go live or delay? Question 3. Day 30 business review shows expected annual outage cost of $5,000, but multi-region will cost $60,000 annually. Do you continue? Take a moment. Answers. Question 1. Investigate before proceeding. Average 180 milliseconds is acceptable from episode 3. But 400 millisecond spikes during peak indicate capacity issues. Peak hours are when you're most likely to need failover. Determine root cause, write throughput, instance size, network congestion. Resolve before adding compute complexity. Go no-go gate 2. If you can't maintain sub 200 ms lag during peak, you can't guarantee RPO during actual failover. Question 2. Delay and fix. 9 minutes versus 5-minute target is 80% variance. From episode 12, this indicates procedure issues. Likely culprits. Aurora promotion taking longer than expected. DNS propagation. Auto-scaling latency. Identify which step exceeds target. Optimize before going live. Going live with known RTO miss will fail business SLA. Question 3. Abort. From episode 15, anti-pattern 1, this is 12 times overinvestment. Multi-region won't pay for itself unless outage risk dramatically increases. Better alternatives. Improve single-region resilience. Multi-AZ deployments. Better incident response. Faster backup restores. Present alternatives to business. Don't proceed with multi-region. Let's recap what we covered. First, 90-day roadmap in 4 phases. Days 1 to 21, assessment and foundation. Days 22 to 49, data layer migration. Days 50 to 70, compute deployment. Days 71 to 90, validation and cutover. Each phase has deliverables and go-no-go gates. Second, Phase 1 establishes business case, architecture design, and network foundation. Don't proceed without business approval. From episode 15, building without justification wastes money and team morale. Third, Phase 2 migrates data layer. Aurora Global Database first, DynamoDB Global Tables selectively. Validate failover procedures before proceeding. Data layer must be reliable before adding compute. Fourth, Phase 3 deploys compute layer. EKS clusters, applications at reduced capacity, secrets replication. Deploy but don't serve traffic. Validate health checks and connectivity. Fifth, Phase 4 introduces traffic gradually. 1%, 5%, 10%. Test failover under production-like load. Only go live when failover meets RTO. Automate DNS failover. Train team. Sixth, post-cutover operational maturity. Cost optimization. Observability refinement. Quarterly DR drills. Multi-region isn't one and done. It requires ongoing discipline. Seventh, abort criteria. If ROI doesn't make sense, if data layer won't stabilize, if costs explode, if team overwhelmed, abort and reassess. Don't proceed blindly. Remember the course journey? Episode 1 introduced the CCC triangle: cost, complexity, capability. Every episode since then taught you how to navigate these trade-offs. Aurora versus DynamoDB. Cost and consistency trade-offs. VPC peering versus transit gateway. Complexity and scale trade-offs. Hot-warm versus hot-hot. Cost and RTO trade-offs. This 90-day roadmap is the synthesis. You start with business justification. You build incrementally. You validate at every phase. You test before going live. You maintain discipline post-cutover. You've completed multi-region mastery. You understand Aurora replication mechanics, DynamoDB consistency models, EKS multi-cluster patterns, network architectures, observability strategies, DNS failover, cost optimization, CAP theorem, service mesh, disaster recovery, compliance requirements, security controls, common anti-patterns, and implementation roadmaps. You can calculate real costs, including the 7.5 times multiplier, and optimize to 4 times. You know when to choose CP versus AP consistency. You can design for eventual consistency. You understand split-brain scenarios. You can implement proper encryption, least privilege IAM, zero trust networking. Most importantly, you know multi-region is a tool, not a goal. From episode 9, run the ROI calculation. If it makes sense, build it following this roadmap. If it doesn't, optimize single region reliability and be honest about trade-offs. The Platform Engineering Playbook is open source. If you found errors, have insights to add, or want to contribute additional examples, visit platform-engineering-playbook.com. Open a pull request. Join the community improving these resources. Thank you for completing this 16-episode course. Build thoughtfully. Test thoroughly. Run the numbers honestly. And remember, the best architecture is the one that solves your actual business problem, not the one that looks impressive on architecture diagrams. The fundamentals remain constant. Understand your requirements. Calculate your trade-offs. Build incrementally. Test extensively. Document everything. Train your team. And when in doubt, start simple and add complexity only when justified. You're now equipped to build multi-region architectures that actually work in production. Use this knowledge wisely.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.